Till now, we have understood these important points about friction. It acts in a direction such that it opposes relative motion or tendency of relative motion. Static friction is equal to force which causes this tendency of relative motion. There is a limit to the amount of static friction a surface can apply on an object. And once the object starts moving, we say kinetic friction is acting. Now we would understand two important things in this video. The first is how to find the limit of static friction applied by the surface. And lastly, how to find the value of kinetic friction acting on a moving body. But before that, let's try to solve this problem. Think about this ladder resting on this wall. It's at rest. Can you think in which direction the force of friction will be acting at these two contact points? I'll give you a hint. Think of the scenario if there was no friction at these contact points. What would have been the nature of relative motion at these points? We will answer this problem at the end of this video. So how to find the limit of static friction? We take the example of our suitcase lying on the floor. Let's compare two types of floors. One is on a rough ground and another on a smooth marble floor. In which case we will need more friction to overcome static friction? Of course, for the rough ground we will need more force to move this suitcase. Hence, the limit to static friction depends on the type of surfaces. We call this factor coefficient of static friction, which is given by μs. It will be higher for rougher surface. Let's now compare two similar suitcases lying on the same floor. But on one of these suitcases, one of your friend is sitting. Which one will be tougher to move? Of course, the one on which your friend is sitting. That is because limit of static friction also depends on the normal force between the involved surfaces. Higher normal force means the two surfaces are more intimately in contact with each other than the one applying lower normal reaction. So, the final expression for maximum value of static friction is μs into n. Again remember, this is the maximum value. In most cases, static friction is only equal to the force which causes the tendency of relative motion between the surfaces in contact. What is the value of kinetic friction applied on the block moving on a surface? That is equal to μk into n, where μk is called coefficient of kinetic friction, which again depends on the nature of the two involved surfaces. Its direction is always opposite to the direction of relative motion. Now the answer to the question we had asked. The ladder resting on a wall seems to be not having any relative motion with any of the surfaces, but there is a tendency of relative motion. We can see that if we imagine a frictionless situation where the surfaces of the wall and the floor are very smooth, it would have slipped. Hence we say the ladder in this state of rest has a tendency to have relative motion in this direction. Hence, these are the direction of friction exerted by the surfaces of the wall and the floor on the ladder. A remarkable fact you can ponder on is that coefficient of static friction is more than coefficient of kinetic friction. That's the reason it's easier to move an already moving object than to move a static object from rest to motion. To sum up what we have learned, let's take a block lying on a floor and start applying force on it. Let's start with 0. Now friction is also 0. But as we increase the force we are applying, the value of friction also increases. There then comes a point when the value of friction cannot increase any further. This point is given by μs into n, which is the maximum value of static friction. At this point the forces get unbalanced and the block starts accelerating. During motion, this block experiences friction equal to μk into n, and if we keep increasing the force, the value of friction will not change anymore.